All right, so today we're going to look at section 3.4, which is on proving lines are parallel. So in section 3.3, that was always the given. You were given that you had two parallel lines, and then sometimes we used alternate interior angle theorem or other theorems. Well, in order to use any of those theorems from section 3.3, you have to know beforehand that you already have parallel lines. If you don't know that you have parallel lines, none of those theorems we learned yesterday work. So that's going to be the goal of today. We are going to prove, using various postulates and theorems, that two lines are parallel. Somebody just remind me quickly, what's the difference between a postulate and a theorem? Jacob?
Postulate you don't have to prove.
Okay, what about a theorem? Yeah, a theorem you do have to prove. So if I ever ask you on a test at some point, do you have to prove a theorem? You would explain, yes, theorems are proven using postulates. And other theorems as well. Okay, so I'm going to give you a postulate. This is the corresponding angles postulate. Corresponding angles converse postulate. Sorry. It says that if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. Okay, all the theorems that I'm going to give you are on page 150. They're all on page 150. So the big difference today is we are learning the converse of all the theorems we did yesterday. So it's very different if you're writing a proof, and when you write the reason, if you write corresponding angles postulate, that's something we did yesterday. If you write corresponding angles converse, that's totally different. Okay, that's a very different reason. And any time that you want to prove lines are parallel, you're using the converses of all the statements we learned yesterday. Okay, so keep that in mind when you're writing proofs. So if two lines are cut by a transversal, so the corresponding angles are congruent, then the lines are parallel. Okay, so what I've done in the diagram is I've given you corresponding angles congruent. And because of this postulate, that proves J is parallel to K. Now that we've proved J is parallel to K, all the theorems we learned yesterday apply, because we know we have parallel lines. Any question on the corresponding angles converse postulate? Okay, and there's three more theorems. Again, I told you the page because they do get somewhat repetitive. They always start out, if two lines are cut by a transversal, so that, and then whatever the statement is. Okay, so theorem 3.8 says, if two lines are cut by a transversal so that the alternate interior angles are congruent, then the lines are parallel. Now that's a theorem, so we have to prove that one. But we can prove it using what we just learned above it, the corresponding angles converse postulate. Any question on theorem 3.8? If you want the picture, that's also on page 150. Yeah.
Does it have to be interior angles?
For this theorem, yeah, for theorem 3.8. But there's other theorems too. What do you think theorem 3.9 is going to say? If you know the consecutive interior angles theorem, you can figure out what the consecutive interior angles converse theorem is. Have a guess, Connor? Do you have a guess what that one says?
It's going to be the same, but not. They're going to be in the same, like, they're going to equal 180.
Right. This is that if you have the consecutive interior angles, they add up to 180, then the lines are parallel.
That's exactly what I'm
So in your notes, I mean, what I might do is just write this first statement once, if two lines are cut by a transversal so that, and just call that statement, something simple. If two lines, and then just put dot, dot, dot. And you already have it from the first example what it is. So you don't have to keep writing it. Okay, so if two lines are cut by a transversal, so the consecutive interior angles are supplementary, then the lines are parallel. That's the consecutive interior angles converse. Right, now, we had one more theorem. Does anybody remember what kind of angles the last theorem had to do with? And it's the same angles we used yesterday. And actually, we did a proof of this theorem, the original theorem, in the homework last night. Yeah? No, it's not. It's not a consecutive one. It's actually the one James asked me to do. It was number 28 in last night's homework. You want to, yeah, Denver? Not sure. What kind of angles did that last theorem we just did have to do? Well, we've used consecutive interior. We've already used corresponding, and we've used alternate interior.
Consecutive? Exterior.
What kind of exterior? Yeah. The alternate. Yep. The last one is the alternate exterior angles converse.
Does it have to be 3.10?
Yeah, because 3.1 is a different theorem. Yep. So, theorem 3.10, if two lines are cut by a transversal, so that alternate exterior angles are congruent, then the lines are parallel. Okay, so some chapters we're going to do, they have quite a few theorems in them. So we just hit our 10th theorem for chapter 3. There are at least a couple more. I think we go up to theorems 11 and 12. Yeah, somewhere around theorems 11 and 12. So you might hit quite a few theorems. So again, if you just need to look at the page and copy it down, that's okay too. Okay, and the corresponding angles converse postulate, that was our 10th postulate. Okay, but those are numbered consecutively from the beginning of the year. So today we just had our 10th postulate of the year. Yeah.
Would you have to prove all of these to prove that two lines are parallel?
No, you could prove any one of them.
Okay.
Okay, let me make them a little smaller, but either theorem 3.10, 3.9, or 3.8, or the corresponding angles postulate. Any one of those is enough to prove lines are parallel. You only need one. Okay, any other questions on those theorems? All right, so what we'll try to do is we'll prove a couple, and then we'll get into some problems that are more numerical. All right. So let's start with the alternate interior angles converse. The number of the theorem, alternate interior angles converse, that is theorem 3.8. So first, just remember what the theorem says. If two lines are cut by a transversal, so that alternate exterior angles are congruent, then the lines are parallel. So what we have to do is prove that 1 and 2, the alternate interior angles are congruent. Oh, I'm sorry, we're given that, 1 and 2. We have to prove that A is parallel to B. Okay, so we're going to go back to the corresponding angles postulate. That's going to help us here. Okay, first thing I've written down is the given. Angle 1 is congruent to angle 2, and the reason is given. All right, what else can we say? And this is a statement we've said quite a few times. How about Rose? What else can we say based? So we know 1 and 2 are congruent. Is there anything else that we could say is congruent there? Well, 1 and 3 are corresponding. We don't know yet that they're congruent. If A and B are parallel, then they are congruent. But we haven't proven 1 and 3 are congruent yet. But that's going to be my third statement. But statement 2 has to get me there. So statement 1 doesn't say anything about angle 3. So in statement 2, we need to involve angle 3 somehow.
Angle 2?
Yep, 2 and 3 are congruent. How come? You want to help her out? Why are 2 and 3 congruent? Katrina?
Definition of vertical angles.
Yeah. So it's the definition of vertical angles. All right. Now we've got 1 is congruent to 2, 2 is congruent to 3. What can be my third statement? How about Dakota? Perfect. Angle 1 is congruent to angle 3. And what would be the reason there?
Definition of corresponding angles?
No, not definition of corresponding angles. What's same as that reason I said earlier, like if A is the same as B and B is the same as C, then A is the same as C. That's your transitive property, yep. So transitive property of angle congruence. Okay, now statement 4, I think we're done. We can now say that A and B are parallel. What's the reason why? Why are A and B now parallel? Yep.
Corresponding angles converse.
Yes. Very good. So the key word he said there, and I was waiting for him to say it, was converse. Corresponding angles converse. That was a postulate. Okay. Because corresponding angles are congruent, we have proven that that proves that the lines are parallel. All right. So now, in any other proofs you have to do in the homework or on the test, you've proven the alternate interior angles converse theorem. So now you can use this theorem as a reason in a proof, because we've already shown why it's true. Okay, any questions on that proof? All right, let's try another one. Okay, the consecutive interior angles converse. So this one doesn't say if the consecutive interior angles are congruent. It's if they are supplementary.
What number theorem is this?
This one was theorem 3.9. 3.9. All right. So I'm giving you that 4 and 5 are supplementary. I want to prove that G is parallel to H. Now you have two ways to prove G is parallel to H. Either you end up with corresponding angles congruent, and you can use that postulate, or you end up with alternate interior angles congruent. You're allowed to use that theorem now because we just proved it. What idea comes up a lot when you talk about proving angles are, or having to do with supplementary? There's a special relationship when you're dealing with angles that are supplementary that can come up sometimes. The two angles form a special pair, a linear pair. All right, so anytime we see supplementary, that idea might come up. Linear pair. All right, what should be my first statement, Ender? Yep, what were we given?
4 and 5 or something. Angle 4 and angle 5 are supplementary.
Good. Angle 4 and angle 5 are supplementary. Reason? Given. Okay, now let's take a look at the other pair of angles there. What about 5 and 6? What do 5 and 6 form? Yeah, 5 and 6 form a linear pair. Okay, so angle 5 and angle 6 are a linear pair. Okay, what's the reason for that? The definition of a linear pair. Two adjacent angles where the non-common side forms opposite rays. So definition of a linear pair. All right. Now what can I say in step 3 because of what I just said in step 2? Yeah.
Angle 4 and angle 6 are, well, linear pair. No, are consecutive interior angles.
Angle 4, well, 4 and 6 are alternate interior. So we are going to use that in a little bit, but there's something else I can say because of statement 2. And the reason is similar to reason 2, but a little different. Yep.
Measurement of angle 5 plus the measurement of angle 6 equals 180.
All right, so yes, angle 5 and 6 are supplementary. What's your reason for that?
Linear pair postulate.
Very good. I'm glad you corrected that. Linear pair postulate. Which says if two angles form a linear pair, then they are supplementary. Okay, now let's look at statements 1 and 3. What you could do at this point is you could say the measure of angle 4 plus the measure of angle 5 is 180. The measure of angle 5 plus the measure of angle 6 is 180. And then if 4 and 5 and 6 both add up to 180, they're equal to each other. And then you end up with an angle 5 on each side of that equation that you could subtract. Now, if you go through all that, you're reproving a theorem that we can use here that does all of that in one step. We don't use this reason a lot. So I can say directly now, angles 4 and 6 are something. Okay? In fact, specifically, I can say they are congruent. Anybody remember the reason why? This is a tricky reason. I'd be pretty impressed if someone remembers it. Yep.
Is that the core it's like congruent
Yeah.
and, I know it's congruent,
And what kind of angles were we working with?
supplementary.
Yep, so it's the congruent supplement theorem. Congruent supplements theorem. If you have two angles supplementary to the same angle, then they are congruent. And I do. I have two angles, 4 and 6, that are both supplementary to angle 5. So that proves angle 4 is congruent to angle 6. Okay, we don't even need to get into talking about measures. Okay, now we've proven 4 and 6 are congruent. I would argue at this point we're done. Okay, but we need the reason why. So G is now parallel to H. What's the reason? How come we can say G is parallel to H? Denver?
Consecutive interior angles congruent.
Consecutive.
No, the one.
Well, that's what we're trying to prove. That's the theorem we are proving. The consecutive interior angles converse. So we can't use that as a reason in the proof. Yep.
And then angles converse partially.
Close. You're missing one word. What kind of alternate angles?
Interior.
Interior. Alternate interior angles converse. Okay, which says that if the alternate interior angles are congruent, then the lines are parallel. Well, we just showed that they're congruent. So G and H are parallel.
Is that a theorem?
Yes, alternate interior angles converse theorem. Hey, any question on proving that? So now in any other proofs you write, you can use this theorem as a reason. You don't have to prove the consecutive interior angles theorem, converse again. All right. So let's try a couple that are a little more numeric. It says find the value of x that would make j parallel to k. So first of all, you got to look at that and figure out what kind of angles you have, and figure out what these two angles are supposed to be that would make j parallel to k. Okay, so how about Justin? What kind of angles are x and 4x? Yep, they are consecutive interior. And the consecutive interior angles are supposed to add up to what? Selena? They're supposed to add up to 180. So can somebody give me an equation involving those two angles and 180 that we could solve? Yeah.
4x plus x equals 180.
Sure. Okay, 4x plus x equals 180. So now this is the algebra part. Okay, you've taken the fact in geometry that the consecutive interior angles are supposed to add up to 180. And now we'll solve that equation. All right, so we've got 4x plus x equals 180. Okay, what's my next step? Sarah? Yep, combine your like terms. And what can you combine?
4x
And how much does that give me? 5x. Okay, my next step? And my last step? Yep, go ahead. Okay, divide by 5. Divide by 5. And let's see what we get. 180 divided by 5 is 36. All right, so now we know that the angle right there is 36. And if they asked you how big the other angle was, you can do 180 minus 36, or you could do 36 times 4. Okay, so that angle is 144. Okay, I don't think they specifically asked for those two angles, but it's not that hard to find. Okay, any question on example 3? All right. Okay, so why don't you try example 4, okay, on your own. It says decide which rays are parallel. So you have ray EA, EB, HC, and HD. All right, and I want to look at a couple things. First, I want to know if EB and HD are parallel, and then take a look at EA and HC. Okay, take like a minute, 2 minutes, and try that one. All right, so first thing we should do is let's just figure out the two angles that we don't know. Okay, in both cases, how do you figure out the two angles you don't know? What's the basic idea here? About Eric?
For part A,
Yeah, well, first, how do we find, let's say, that angle right there?
it would be 3.8. So it'd be 58 degrees.
Well, we don't know yet what theorem we're going to use. For now, we just want to find this angle. And it's not going to have to do with a theorem we learned today. It has to do with what all the angles on a straight line add up to.
Oh, okay. It'd be 60 degrees,
Okay, and how'd you get that?
because I added 62 and 58, and
Okay, so if we add those up, you get 120.
then 180 minus 120 was 60.
Good. Okay, so we know that one's a 60. And we could do the same thing on the other side. Add up 59 and 61. Same thing, 120. So angle, let's see, CHE is also 60. Okay, now I think we have enough information to answer. Okay, is EB parallel to HD? What do we think? Is EB going to be parallel to HD? Think, Olivia? No. If you can, let me see. Yeah, if you take out the segments you don't need for now, just look at the two. You have two lines cut by a transversal, and you're looking at this angle and that angle. And if they were congruent, then by the corresponding angles postulate, ray EB and HD would be parallel. But the angles aren't congruent. One's 58, the other is 61. Okay, so in this case, the answer is no. Okay, now let's put these back.
We locked them in.
Oh, did I switch them?
Yes.
All right, now we're looking at the other two. Okay, we're looking at EA and HC.
You didn't need to, for that one, you don't need to prove the 60 degrees.
No, for part A, you do not need to figure out that the other part was 60.
Part B,
Part B, yeah, there's a couple ways you could do it. You could have just added up what was there and realize that they're both 120 on that side. Right? Yeah, you're right. So is part B yes or no? Yeah, that is true. Okay, so part B is yes. Okay, any questions on that? All right. So the homework on 3-4 will be page 153. Okay, and it's 3 to 12, 16 to 18, 19 to 23, and then 26, 28, 32, and 34, all. And for MCAS questions tonight, we'll do 5 through 8. Okay, multiple choice 5 through 8.